Okay, so hopefully we just reviewed a few things from pre-cal about inverse functions, right? Just kind of enlightened us again on the beauty of them. And also we discovered some things with calculus in terms of derivatives of inverses. Okay, you might be thinking, Ms. Kay, why are we going back to this? This seems kind of weird. We just talked about natural log functions and how to integrate and do derivatives and stuff, right? This is actually a needed tool to get us to the next lesson, because in the next lesson we're going to talk about e to the x, which is the inverse of natural log. So we need this as a tool to help us discover things about e to the x. All right, so here we go. So the definition of an inverse function, you guys know this definition. It was given to you in pre-cal, right? You can read this for yourself, but you know when you compose them both ways, we should get x, right? And this is the symbol that we use. Okay? All right, so real quickly, let's graph f with its inverse. So f is just the parabola. Can you tell me what the inverse of this guy is? Square root of x. And we know these things, right? We can swap x's with y's and solve for y, but I think we understand that that is the inverse function, right? By the way, why did we have to do this to the parabola?
Because
Right, and so f of x equals x squared is a parabola that is not one-to-one. Do you remember these words we used in pre-cal? It's not one-to-one, so we have to cut half of it off to restrict its domain so that the inverse of it will indeed be a function. Okay? All right, so if we graph them, go ahead and just kind of sketch them. I know you can do that real quickly. 0, 1, 1, 2, 4, 3, 9. All right, so here's the right side of my parabola. I'm restricting the domain. And then do the square root of x as well. So 0, 0, 1, 1. We swap x's with y's. So now I have 4, 2, 9, 3. And this guy's actually, the concavity is different than the other one. All right, and we know some things graphically. You told me in the little activity that x's and y's get swapped. You also told me there was symmetry about the line y equals x. Isn't that what you told me? We noticed that? Okay, but let's figure out some calculus things that are going on here. So we need to find the derivative of f and the derivative of f inverse at particular values. So I need to find slopes of tangent lines. That's what I'm interested in, right? So probably what I should do is find the derivative of f, which is what? 2x. And I also need to find the derivative of the inverse function. And here's the notation for that.
1 over 2 root x.
1 over 2 root x. I'm so glad we can jump into that and just be done with it, right? Everybody's okay with that? Okay, we're in Cal 2 now. Everybody's good, yeah? Okay. So let's evaluate the slopes of tangent lines on the f function at these particular points. So when x is 2 and y is 4, how do you find the slope of a tangent line? What do? You input 2, right? And you also input 3. So when you input 2, you get 4. Input 3, you get 6, right? So this guy is 4, this guy is 6. Now, notice on the inverse what happens. X's and y's get swapped, right? So over here, we're going to find f inverse prime of what now? 4. Not 2, right? But 4. So what do we expect to get? The reciprocal, right? 1/4. And if you input 4 into this function, you will get 1/4. Is everybody okay with that? Do the same thing for f inverse prime of 9. So we plug 9 into this, and that'll give us 1 divided by 2 times 3, which is 1/6. All right. Now, guys, this is very easy. However, you can get royally confused with this. Do you understand how this can happen to you, getting royally confused? You have to swap x's with y's, right? And slopes are reciprocals of each other. Okay. So this next thing, is everybody good so far? We're good? Yes? Okay. The next thing I want to show you is basically a proof, very, very short proof, very basic. You'll enjoy this one, okay, of how we can come up with a formula for, if I know that g is the inverse of f, then what would g prime equal? What would be the derivative of an inverse? This is actually what's going to be needed for our next lesson. right? So what do we know about inverse functions? What's a true definition of inverse functions?
That f of g of x equals x.
F of g of x equals x, right? Isn't this the true definition? And the other way as well, right? But we'll choose one to get this definition. What if I were in calculus class one day, right? And what if I was like, I wonder what the derivative of this equation would be with respect to x? Okay, so don't we know how to take the derivative of f of g of x? It's the chain rule. Very good, awesome. So f prime of g of x times g prime of x. You guys have seen this notation before from Cal 1, right? That's the derivative of f of g of x. This chain rule equals 1. And what if I'm trying to figure out, well, what is g prime of x equal? What is the derivative of the inverse? What could I do? Very good. So g prime of x is going to equal 1 divided by f prime of g of x, right? This is what we're going to be using to help us figure out derivatives of inverse functions. Okay? We good with this? All right. And so up here in this definition, you'll notice why I had to say that this cannot be 0.
Because then you have a 0 on the bottom.
Very good, very good. So I had to kind of define that to make sure that that doesn't happen. All right, so let's check out this second problem here. It says, let f be this cubic function. Okay, let f be this cubic function. The first thing I need to do is find f inverse of 3. I need to find f inverse of 3.
Can't you just put 3 in and then take the y value?
Okay.
No, but the y value has to equal.
So here's my f of x business. Here's my f inverse of x business. And sometimes I do this so that I don't get confused. Okay? So here's a coordinate, here's a coordinate. And so I'm asked to find f inverse of 3, right? So when x is 3 on the inverse,
Y is 3 on the regular.
y is 3 on the regular, right? And guys, I do not want to have to find the inverse of this function and then evaluate it. I don't want to have to do that. Because I would have to swap x's with y's and solve for y, and that would be a pain and pretty much almost impossible to get it in explicit form. Okay? So what can we do?
You just set it equal to 3.
We're going to set it equal to 3. Set the function equal to 3 to figure out what x value will help us there. And I'm going to let you use your calculators to figure that out. Okay? Use your calculators to figure that out.
Isn't there?
Very good.
I was just making sure.
Just reason through that in your head?
Yeah, I just subtracted it over.
Oh, cool.
Since
Figured out what
tried
it should
because
okay,
I assumed
cool.
it was a round value.
Awesome. So if you had a calculator to look at, what could you do to help figure this out? What would you do?
Put the graph on the table.
Okay, cool. So put this guy in a graph and figure out, using a table, what x value would give you a y value of 3. Sometimes that works. Sometimes that doesn't, because the x value is not a number that pops up on the table.
Could you
Right.
not input a value into the table and see what?
You can.
That'll take a little while.
You can. You have to change your format of your table if you want to do that.
Um,
But this one's a nice number, I believe. Yes.
I found the inverse function.
Ah, cool.
Third root of 4 minus 4x.
Is it? Cool. What did you get for x here? 2? So then, what does that mean on the inverse? 2. So Alex, put 3 into your inverse and see if you get 2 as the output to make sure that it is correct.
I got -2 actually.
Really? Something happened then. Okay, so I knocked this guy out. So we know that f inverse of 3 is equal to, what did we say? 2, right? So I answered that question. Is everybody okay with that? The next question says, I want you to find f inverse prime of 3. Okay? So according to the definition that we just wrote down, it's going to equal what? 1 divided by f prime of, instead of using g, we're calling it f inverse, right? F prime of, I just called it g, didn't I? Sorry. F prime of f inverse of 3, right?
You know this.
Inverse of 3 is 2.
Very good. We know f inverse of 3 is 2, right? So this is actually going to be the same thing as 1 divided by f prime of 2. And we probably could have already figured that out, right, based on things we've learned so far. It's going to be the reciprocal of the inverse of that, right? Okay, so now we need to figure out, well, what the heck is f prime of 2? Can we find f prime of x very easily?
Yes.
I believe so. So what would f prime of x be?
3/4 x squared plus.
All right. And then finding f prime of 2 is not that big of a pain,
4.
right? Because 2 squared is 4. No, we're finding f prime of 2.
4.
So we get a 4 there. If you work that out, we can do that, right? That's not terrible. So this turns into what?
1/4.
1/4.
I ended up with the same answer.
Did you? Okay. Okay. Cool.
Hey, so, how do you get, how does it go from the second step right there?
What
Like,
second step?
Right
Right here?
at the top right. I mean, top right. Top
Right here?
Yeah, well, how does it go from F, to the,
That?
inverse of that? To the three, yeah.
Okay, so we know that f inverse of 3 is equal to 2 because we just worked that out previously. It was asked of us to figure that out.
How are you getting that, within F prime?
Oh, where did this come from?
Yeah.
It came from this definition that we wrote down right here.
That's all.
So G is the same thing as F inverse.
Yeah.
That's where that came from. Okay? All right, so if you'll flip over, let's do this next problem. So I wrote it in this form here because this is the way some of your textbook problems will ask. For some reason, they put A's in there. So basically, this is just asking what? What is F inverse prime of A when A is negative 1/2, okay? So we need to figure that out. Now listen, I know that you know what the inverse function of cosine is, right? What is the inverse function of cosine? Arc cosine? Arc cosine, inverse function, right? So arc cosine. Do any of you guys know the derivative of arc cosine?
No.
No, you will soon. Okay?
What is?
But you don't know it just yet. So we can't go that method. All right? So now let's figure out what we got. All right, so we are trying to figure out f inverse prime of negative 1/2. Isn't that what we have to find? So according to that definition, it's going to be the same thing as 1 divided by what? F prime of
F of a negative 1.
f to the negative 1 of negative 1/2. Isn't that right? So it's going to be important for us to figure out what is f inverse of negative 1/2. That is going to be important for us, right? So what is f inverse of negative 1/2? Well, that means when x is negative 1/2 on the inverse, which means when y is negative 1/2 on the function, right? So when does cosine equal negative 1/2? When does that happen?
4 pi over 3.
And we're restricted on our domain. We can only be between 0 and pi. So it needs to be over in the second quadrant, right? It's 2 pi thirds. It is 2 pi thirds. Very good. So that happens at 2 pi thirds. Everybody with me? So 2 pi thirds is the x value on the function, which means what to us?
It's the one thing on the
It's the y value on the inverse, right? So we can keep going with this idea here. This is 1 divided by what? F prime of, what did we say F inverse of negative 1/2 was? 2/3, is that right? So now we just have to evaluate 1 divided by f prime of 2/3. What is f prime of x?
Negative sign.
All right, so f prime of x is negative sine x. All right, so we need to find f prime of 2/3.
Negative root 3 over 2.
So the sign of 2/3 is positive, right? But there's a negative on the outside. So we would get 1 divided by, it's negative, right?
Negative root 3 over 2.
So that's just asking for the reciprocal. So negative 2 divided by root 3 should be the answer. Are we good with that? Okay. It is quitting time. So here's what I need you to do, guys. I need you to work through this one. And I also need you to work through this guy. And there are some problems in the textbook I need you to work through. Don't forget about these two because we're going to go back to them. Let me stop my recording for just a second.